Hello viewers, welcome back to my channel Knowledge for You. Today I am going to discuss the most important questions which comes for 3 marks for diploma students. They may be from any background, that is computer science background or electrical and electronics engineering, electronics and communication engineering. They will be having the common subject digital electronics. So I am focusing the 3 marks most important question you can expect for your end semester examination. In the first one we have the classification of counters. The counters are classified into two types. First one synchronous and next asynchronous. And here the difference between synchronous and asynchronous counters follows. Before that, asynchronous counter is also known as ripple counter. So don't get confused. He may ask you either the difference between synchronous and ripple counters. Then don't get confused. Indirectly, it means that ripple counter means asynchronous counter. So here the differences goes. The first one, synchronous counter, clock is applied simultaneously, whereas in asynchronous counter, clock is not applied simultaneously. So you can write the opposite statement of synchronous counter. In a synchronous, clock is applied simultaneously. In asynchronous, clock is not applied simultaneously. So you can see from this diagram, here we are applying the clock simultaneously to these two flip-flops, but here we are not applying simultaneously. The clock is applied only to the first flip-flop, whereas the second flip-flop will be driven by the output of the first flip-flop. That means the second one clock is applied from the output of the first one. So second point is it's the fastest one, it's the slowest one. As the clock is applied simultaneously, so obviously the synchronous counters are fastest, whereas the asynchronous counters are slower. Next, since it is fastest, therefore synchronous counter does not produce any delay. Asynchronous counter produces delay. The examples for synchronous counters are parallel adder, and the example for asynchronous counter is serial adder. And here we can take the inputs of the synchronous counter. So what are the inputs of synchronous counter? Means JK inputs, SR input, D and T inputs. These are considered examples of it. Whereas for asynchronous, preset and clear are considered as asynchronous inputs. Preset and clear are considered as asynchronous input. So I hope that you have understood this. So once again, in synchronous, clock is applied simultaneously. In asynchronous, clock is not applied. Synchronous is fastest, asynchronous is slowest. Synchronous does not produce delay, asynchronous produces delay. And example is parallel adder, serial adder. So you can write these differences for 3 marks. Each point carry half mark. Each point carries half mark. Do remember that. And the next classification we have triggering. What are the types of triggering? It is also important question for 3 marks. There are 2 types of triggering: edge triggering and level triggering. So see here, if it is asked for 1 mark, then you have to write only triggering is of 2 types: edge triggering and level triggering. But if it is for 3 marks, then you have to classify it clearly that edge triggering in level triggering. Again, edge triggering is classified as positive edge, negative edge, and level triggering is classified as positive level and negative level triggering. The next question is clock. So clock is a rectangular pulse train or square waveform. So here I have shown you the diagram of a clock. It is a rectangular pulse train or it is a square waveform. So why I have drawn this clock signal means because if you get the question for 3 marks, then you have to draw this positive edge triggering, negative edge triggering with the help of diagram. So it shows the diagram here. So here we have the positive means the rising edge of the clock pulse. The rising edge of the clock pulse is called positive edge triggering, and the falling edge of the clock pulse is called negative edge triggering. Similarly, this is nothing but positive level triggering and this is the negative level triggering. So you have to explain your answer with this diagram. So it completes your 3 marks. And the next one we have 4-bit synchronous counter. So you can expect the diagrams for 3 marks, that is 4-bit synchronous counter. 4-bit synchronous asynchronous counter. It is also called as mod 16 up counter. Up counter. So why we are calling it as up counter means because it counts in the ascending manner. 0, 1, 2, 3, 4, 5, 6, so on. Still, it counts till 16 states, therefore it is called as mod 16 up counter. So here are the diagrams. So this is the only diagram you can expect for 3 marks. So see here, 4-bit means we have to use 4 flip-flops, 1, 2, 3, 4. So I have used here 4 flip-flops. And do remember one thing, to design a counter out of all the flip-flops, we prefer only JK flip-flop. So why do we prefer only JK flip-flop for designing counters? Then the answer is in JK flip-flop we get the toggle condition. we get toggle condition. So I have already told you in 1 mark question what is toggle. If you did not go through it, please go through my previous video so that you can understand what is toggle. So but once again, let me clear that toggling means when j is equals to 1, k is equals to 1 and clock is high, then we call it as a toggle condition. So see here, to make it a toggle condition, so these inputs, all the inputs j0 k0 are the first flip flop, j1 k1 j2 k2 and j3 k3, all these 4 inputs are connected to the logic high or logic 1, that is plus 5 volts. And next, since it is asynchronous, therefore the clock signal is applied only to the first flip flop and the remaining flip flop will be driven by the output of the previous flip flops. Look at here, this flip flop is receiving the clock from this output and this one is receiving from this one and this one is receiving the clock from this one, q2. Okay, that's why we are calling it as asynchronous and it's the slowest one. It produces a delay. The example is serial adder, which we have already discussed. And which type of clock we are applying here? It is a negative edge triggering. So how can we identify it is a negative edge triggering or positive edge triggering means? Look at this. So this is an arrow indicates what edge triggering, and here we are putting a bubble. So whenever bubble is inserted before this arrow, it means it is a negative edge. If you don't insert a bubble before this, it is a positive edge triggering. So like that you can understand which one is positive edge, which one is negative edge. But in this diagram we are using a negative edge triggering. Okay, this is a diagram. So you can expect this diagram for 3 marks. Okay. So similarly we have decade counter. So why I have explained decade counter immediately after to this 4-bit asynchronous counter means it is also a 4-bit counter, but it is a decade counter. Why we are calling it as decade counter means it is a counter which can count up to 10 states. It is a counter which can count up to 10 states. That's why we are calling it as decade counter. So it is also known as mod 10 counter. Mod 10 counter. Mod nothing but modulus of a counter. So which counts modulus of a counter? Modulus means the total number of output states of a counter is called modulus of a counter. So this is a diagram for decade counter. Here we have. So look at here. The reason why I have drawn immediate decade counter means because you can easily remember the diagram. If I don't put a NAND gate here, if I hide this NAND gate connection, then the above 4 flip-flop indicates the connection of 4-bit asynchronous counter. This is a diagram which resembles the 4-bit asynchronous counter, or you can say as it is a diagram you can draw, and additionally you have to draw a NAND gate here. For this NAND gate you have to give the inputs like Q3, Q2, Q1, Q0. Okay, so Q3, Q2, Q1, Q0. So why I have given Q3, Q2, Q1, Q0 means look at here, Q3, Q2, Q1, Q0. It has to stop counting once it receives the 10th clock pulse. Okay, it has to we are forcing the counter to stop once it reaches the 10th clock pulse. So the binary value for the 10 is 1010. So Q3 is 1. That means we have connected Q3 directly. Q2 is 0. So we have to connect Q2 by means of a NOT gate. And Q1 is 1, so we have to connect Q1 directly, and Q0 is a NOT gate, so therefore it is 0. So the output of this NAND gate we have to apply to the clear signal, so that whenever it receives the 10th clock pulse, then it makes sure that the clock signal gets activated and it makes the output of all these flip-flops to reset to 000. That's how it behaves like a decade counter. That's the reason I have drawn this decade counter immediately after to 4-bit asynchronous counter. Okay, so please practice this diagram once again. I hope this information is useful to you. Please like, share and subscribe to my channel for further updates. And I'm continuing to give services to you to get passed in your diploma in an easy manner. Thank you once again.